Welcome. If you're ready to modernize an old analog CCTV setup, this guide walks you through a practical, cost-effective upgrade to a smart IP system. I'll cover assessment, hardware choices, network setup, and testing so your system gains higher resolution, AI features, and reliable remote access. Step 1. Assess your current system. Start by auditing your existing cameras, DVRs, cables, and mounting. Note camera models, lens types, cable lengths, and which cameras show acceptable image quality. Identify which analog cameras are worth keeping and which should be replaced. This assessment helps prioritize upgrades and control costs. Step 2. Decide reuse versus replace. For cameras you want to keep, plan to connect them using video encoders or a hybrid XMeye that accepts both analog and IP inputs. Replace older or low-resolution units with IP cameras where you need higher image quality or AI features like face or vehicle detection. Step 3. Choose core recorder management platform. Select an NVR, NAS, or VMS that supports your camera count, desired retention, and analytics. For small installs, an NVR with built-in PO can be easiest. For larger or scalable systems, pick VMS software running on a server or NAS for flexible recording, multi-site management, and advanced analytics. Step 4. Pick the right IP cameras and features. Choose IP cameras that match your needs, resolution, lens type, low light performance starlight, and onboard AI analytics if required. Consider fixed versus PETS cameras and whether you need built-in mic or audio features. Step 5. Plan power and networking. Use PO switches to supply both power and data over one cable. It simplifies installation and centralizes power. Ensure switch capacity PO wattage matches camera draw, and plan VLANs or separate subnets to separate camera traffic from general network traffic. Step 6. IP addressing and network configuration. Assign static IPs or DHCP reservations for cameras to ensure consistent addresses. Configure subnets, gateway, and DNS properly. If remote access is needed, plan for secure methods, P2P cloud services, VPN, or properly configured NAT with strong security. Step 7. Physical installation and cabling. Run new Cat5e Cat6 cables where necessary. Keep cable runs within spec for PO, and reuse existing coax runs only if using encoders. Replace damaged connectors, use weatherproof junctions outdoors, and mount cameras for optimal field of view and minimal glare. Step 8. Integrate encoders. Hybrid devices connect analog cameras to encoders or a hybrid XMeye so footage becomes available on the IP network. Configure encoder stream settings to match your NVR or VM's expectations and test each converted channel for clarity and sync. Step 9. Configure recording, analytics, and storage. Set recording schedules, retention policies, and bitrate or frame rate per camera. Enable AI analytics where needed and tune sensitivity to reduce false alerts. Choose local storage size or cloud options and confirm retention meets your policy. Step 10. Test remote access, users, and maintenance. Test live view and playback from phones and laptops, verify alert delivery, and create user accounts with role-based permissions. Plan firmware updates, backup configurations, and a maintenance schedule. If you need secure remote access for multiple sites, prefer VPN or enterprise cloud services over open port forwarding. That's your upgrade path. Reuse what makes sense, add IP cameras for better image quality and AI, centralize recording on an NVR or NAS or VMs, and secure the network. The result: scalable, smarter surveillance that's easier to manage and far more powerful than old analog setups.